Hello guys, welcome to another session on machine learning series. Today we'll basically try to understand how optimization actually works. More specifically, we'll basically try to understand how gradient descent actually works. So gradient descent is actually one of the most interesting optimization algorithms. So it's actually sort of the basic for whole of machine learning. So obviously there are certain disadvantages to it as well, but it's general principle, right? So whatever general principle you would be seeing over here, it's sort of applied right from machine learning to deep learning. So this is sort of the basic building block. So if you actually understand what is happening over here, what is happening in gradient descent, you should be able to pick up more complex optimization algorithms. So basically, we'll try to run few code examples of gradient descent, wherein we'll basically try to code up gradient descent algorithm, wherein we're trying to get the best values of weights for a linear regression. Right. So before that, this is what previously I think we just discussed. So we were just discussing what is the hypothesis function of a linear regression. Again, in this particular case, we had basically discussed in terms of beta, but this is just variable, so you can just represent it by any variable, right? Over here it's theta, so all of it are the same. General equation say you have your x naught. So in this particular case, x naught is 1. Beta naught plus beta 1 x1 plus beta 2 x2, right? And the cost function is your mean squared error. And what basically is the cost function, right? So you're taking the mean of the squared of your error. So this is what the optimization algorithm is. So what basically a gradient descent gives you, right? So your input to gradient descent is nothing but basically what you're trying to minimize. In our particular case, right? In our particular case of linear regression, what we are trying to minimize is our cost function, right? So that is the input. What is basically the output is the values of your weights. Your weights could be beta naught, beta 1, beta 2. It's nothing but the optimal values for which, right, your cost function is minimum. So that's what the output of this is. This is again one more representation of your linear regression hypothesis function, right? So you have your beta naught, beta 1. So these are nothing but your weights. Then this is your random error term. So this is what is your cost function, your mean squared error. So let's go back to your gradient descent. So gradient descent basically, again, it's type of optimization algorithm. So in optimization, right? So there are, in a more simplistic explanation, there are basically two types of functions. There is something which is called as convex functions and concave functions. So what basically convex functions are, in convex functions, basically what we are trying to find out is the minima. Okay. So minima, what is the idea of minima is sort of the lowest point, like the lowest point in a function. So that's what we're trying to find out. Okay. In a convex function, concave function, what we generally try to find out is the maxima. So maxima is sort of the maximum point on this particular function. In this particular case, we use gradient descent for convex functions. Like gradient descent is basically used to get the minimum of a particular function. So that's why we use gradient descent. For getting the maxima, there are other terms, something like gradient ascent and all of that. But for now, our focus would mainly be on gradient descent. Okay. So we'll just start off with writing first. Right, again, the idea is the same. You have your same linear regression, right? So you have same hypothesis function, you have your same cost function. But basically, what we'll try to get to is we'll just basically try to understand how it actually works. So most of the times, whenever you actually code it up, right? Most of the times, whenever you code it up, it would be easier to understand. Right. So we just. Yeah, so what basically this function is telling us is we are just basically through this function we are basically trying to get the error, right? So your error in this particular case is nothing but your cost function. So cost function is nothing but your So this is what you will be basically trying to minimize for a line given. So given points, you're just basically trying to figure out what is the error. Say B. So these are nothing but your arguments. I think this is a very standard Python function, nothing specific about it. Right. So there is nothing specific. It's nothing but your standard function. So basically what we are doing in this is we're looping through each point. So we'll be having our X and our Y values, right? So from those X and Y values, we'll basically try to figure out, or try to get the value of the error. So I'm getting my X. So this is the X, and I'll have my Y as well. Right. So again, so I have the Y. So it'll give me the same thing. So it has to be the Y. So after the X and the Y, basically calculate the total error. Right. So total error is nothing but so this Y. So difference between your actual and your predicted. Right. So just trying to figure out the difference. So obviously squaring it, because after, then you take a mean as well. Right. So you just return. So mean, I think you can just take it at the end, right? Mean of length of float of length of. Right. So this is a function for computing the error. Yeah. Next, this thing is you basically need to calculate. Next step is basically writing the function for calculating the gradient. So this gradient descent, right? Gradient descent. So what is actually gradient descent? So basically, we'll just discuss gradient descent in a more sort of in a more simplistic manner, right? So consider this is a top of a hill, right? So this is a top of a hill, and you're basically at some point maybe over here. Okay, so you basically need to reach the bottommost part of the hill, right? So how do you basically go about, right? So the whole idea is say how do you go about and reach the bottommost part of the hill is you basically take gradients along each point. So if this is your initial position and you need to reach to your next position, how you basically decide on which direction to go, right? So basically you're at this position, you can actually take any number of directions. You can basically go in this direction, go in this direction, go in this direction, right? You can basically go in n number of directions. So how do you decide on which direction to go is where your gradient helps. So gradient is nothing but your derivative, right? So derivative, you just take a differentiation of your function of or whatever you're trying to minimize. So that will basically tell you in what direction to move. Right? It will tell you the direction as well as the magnitude as well. Magnitude, as in say at this position, say through calculating the gradient, you know that you should actually go in this position. It will also tell you which direction to move as well as the magnitude. So this is what gradient descent actually is. So it will basically help you in reaching the minima. It will basically help you in reaching the lowest point. So how is it all possible is you basically take the derivative. Okay. So in this particular case, you basically take the derivative of your cost function, basically whatever you're trying to minimize, right? So you take a derivative of your mean squared error. And one more explanation of how does actually grade taking a derivative helps in knowing which direction to move, right? So derivative is nothing but your rate of change, right? So in this particular point, say if you take a derivative which is nothing but slope, it's nothing but rate of change with respect to that particular point, right? So it's nothing but, you can think of it nothing but a nudge, right? You're just trying to push from this point to another point. So depending on your derivative, so if you actually give it a push in this direction, you get a positive gradient, right? Your slope is positive. It basically means you need to go in the opposite direction, right? Because in whatever direction you give a nudge and you actually there is an increase in the value, it basically means you're going up, right? So you need to go in the opposite direction. and how much magnitude, what should be the magnitude of your next step is. So simplistically, you can just take whatever value of gradient you have, right, and you can just get to the next values. But one problem which is generally seen is that as you take larger steps, right, there is a general there's a general chance of missing your minima. So you can just you'll just overshoot the minima, and you tend to again repeat this whole cycle, right? It just goes in a loop. So not to overcome this particular problem, what is generally used is something which is called as learning rate. So whatever gradient value you get, right, you sort of multiply that value with your learning rate, so that you can actually take smaller steps. Right? The problem with taking larger steps is there's always a good chance that you'll overshoot the minima. Right? When you overshoot the minima, then again the whole process should repeat. So this whole gradient descent is sort of an iterative process. So it's like you run it for the first iteration, and if the stoppage condition is not met, you again continue. So you keep on running this iteration.